Hello everyone, my name is Manuel Hafner, and today I will do a training with you on the topics Agile and Scrum. A quick hint at this point, this training is available in English and German. This will be today's agenda: Agile methods, Agile Manifesto, Kanban board, Scrum, the customer in focus, Agile estimates, the thing about the plan. First we take a look at the Agile methods. Cynefin framework. Cynefin comes from the Welsh and stands for habitat and sense of place. The Cynefin framework helps to evaluate where we are and how we can deal with the problem. As you can see, we have 4 quadrants here. Clear. An example of a clear problem is that you see that your shoe is open. You sense that the shoe is open, you categorize that as open shoe, and you respond to it. Most likely, you all respond in the same way. That is, if the shoelace is untied, you all tie it again. So there is a best practice and there is little variability. Complicated. Complicated problems are a bit different. An example of a complicated problem would be clockwork with gears. There, it's not so simple anymore. You don't look at it, categorize it, and everyone does the same thing. Instead, in order to repair a broken clockwork, you will probably first have to look inside, that is, sense, then begin to analyze. You ask yourself, how does one gear fit into the other? How are the components connected? You form a model and look at how cause and effect are connected. Based on this model, you then respond. For this, you need experience, knowledge, and then also good practice, which watchmakers apply. But maybe there are different ways to solve the problem. It is not as clear as it was with clear problems, but there are still good practices that can be applied. Complex. Complex tasks are such that we no longer analyze everything and put into cause-effect relationships. It's just too much, and we don't even know what to look at. But we can do something, and then sense what happens with it. In a complex environment, there are still cause-effect relationships somewhere, but they are much more difficult to find. They are also much more case-dependent. Today, looking back at how COVID-19 changed our world, for example, we can see connections. But we couldn't have foreseen it at the time. There were simply far too many connections that we would have had to take into account at one time or another. That's what makes complex issues. In complex problems, There is no good or best practice, but we speak of emergent practice. Emergent practices are practices that develop because we do something, collect feedback, try to extract patterns from it, and then try to transfer these patterns into a new practice. Complex problems are interdependencies with other people and companies, where we have political systems, so where many different perspectives come together. We have suppliers, cooperation partners, competitors, and we live in a world where a tweet from a US president can upset the economic system. Here you are certainly at complex or even already at chaotic problems. Chaotic. I don't want to go into chaotic in detail, because I hope that we will have less to deal with it. Even if it sometimes seems that everything is chaotic. In the chaotic system, even in retrospect, we no longer recognize any connections. So there is no cause-effect. Therefore, we can only do something and see whether it has brought something. We react and hope that we have done the right thing. We need a novel practice for each task and each problem. This model helps us to understand what task we are dealing with and how we are dealing with it. We will see later that agile approaches like Scrum and Kanban usually help us to solve our complex tasks. Classical management principles like long-term planning, departmental handovers, sequential working processes, these are all things that have worked well in complicated environments, but reach their limits in complex environments. Through methods, we can try to absorb some of the complexity. For example, we can set priorities in such a way that the complex problems become complicated problems again, in their own way. You are then still in a very complex environment, but the individual tasks you are now dealing with are more likely to be considered complicated. Here is now your first question. You have 15 seconds to answer the following question. Cynefin means time is over. The right answer is habitat. Let's see what other tools we can use besides Scrum to work in complicated and complex environments. Say we get complicated or complex problems. Then we need a tool like the cause-effect diagram. The cause-effect diagram, also called Ishikawa or fishbone diagram, is the visual representation of causes that lead to or significantly influence a result. All causes of problems should be identified and their dependencies shown. The best known form was developed by the Japanese scientist Kaoru Ishikawa in the early 40s and later named after him. The Ishikawa diagram was originally used in the context of quality management to analyze quality problems and their causes. Today, it can also be applied to other problem areas and has found worldwide distribution. The basic problem is entered at the right edge of the diagram, the end of the main bone. The possible causes of the problem are drawn as bones on the main bone. Brainstorming usually involves adding possible causes to the main bone and more specific causes to the bones on the main bone. This subdivision into more and more specific causes continues as long as the problem areas can be further subdivided. When the fishbone is complete, we have a complete picture of all the possibilities of what could be the cause of the named problem. Now, what does a filled Ishikawa diagram look like? Here is an example. Our problem is a blurred photo. After we have identified the four main influencing variables: equipment, process, environment, and user, we go into the details. For our equipment, a dirty sensor could play a role. For the environment, the evening darkness or shadows could play a role because it is too dark to take a good photo. Based on this, we can now identify possible courses of action for solving the problem or achieving the goal. Another handy tool is the 5W method. It is a questioning method used to identify the root cause of a failure or problem. The method was originally developed by Sakichi Toyoda and was used within Toyota Motor Corporation during the development of their manufacturing methods. The method has been widely adopted and is now used within Kaizen, Lean Manufacturing, and Six Sigma. Suppose our car won't start. The problem is clear, but what is the root cause? We can now approach the problem. Why is the vehicle not starting? The car's battery is dead. Why is the car's battery dead? The alternator is not functioning. Why is the alternator not working? The alternator belt has broken. Why has the V-belt broken? The alternator belt was well beyond its useful service life and not replaced. Why was the V-belt never replaced? The vehicle was not maintained according to the recommended service schedule. There could be more why question levels. It is not limited to 5. Generally, 5 levels are enough to get to a root cause. The key is to avoid assumptions and logic traps. Instead, we follow the cause and effect chain in direct steps from the effect to a root cause that still has some connection to the problem. Okay, Houston, we've had a problem here. Imagine we have parked a lunar roving vehicle on the moon, come back and see that the tires have been stolen. After realizing we have a problem, what's next? A. Ignore it. The problem may go away. B. Blame it on another team. C. Blame it on the business owner. D. Blame it on another program. E. Create a corrective action plan. Which are the right answers? The answer is E. Create a corrective action plan. What is a corrective action plan anyway? Corrective, a different course of action. Action, active steps we can realistically accomplish. Plan, organized, purposeful, accountable, measurable. Let's look at a corrective action plan based on an everyday problem in many offices around the world. Describe the problem. Describe the problem in hand. Can be detailed or summarized. Every time I want to drink coffee, I have to find a coffee package and then refill coffee beans. Identify root cause. Identify the root cause of the problem in hand. No one feels responsible to refill, and the coffee packages are always lying somewhere else. Identify corrective actions. How to immediately deal with the problem in hand. Find the coffee beans and refill them. Can this be done even better? Yes, if we now combine corrective actions with preventive actions, we get a satisfactory result. Identify preventive actions. How to prevent this issue from happening going forward. First, a sign asking for refilling. Second, choose a place to put the coffee packages. Execute and close action points. Act on the identified corrective and preventive action. First, print out a sign and hang it next to the coffee machine. Second, make space on the shelf and label it. An assembly line of the Ford Motor Company. Henry Ford was an American industrialist and business magnate, founder of the Ford Motor Company, and chief developer of the assembly line technique of mass production. Complexity has increased massively over the past decades and centuries. On the far right, we see what we have already seen in the Kanban framework, which is that many things are now at a high level of complexity. Let's take a look on the first production line for pork packing in Cincinnati. The print showing 4 scenes in a packing house: killing, cutting, rendering, and salting. When we talk about the history of agility, we usually start around the 19th century. We are not yet talking about agility directly. Frederick Winslow Taylor. A milestone was set then that is still very dominating and important today. Mr. Frederick Winslow Taylor, a US-American engineer, founded the so-called Taylorism, officially scientific management. His idea at that time was to separate the execution work from the mental work, that is, the preparation and the thinking work. That means he divided into 2 departments. In one of them, people thought about how to do the work best. And then there were very clear instructions on how the workers had to shovel, for example, or carry out any other manual work. That made companies massively efficient at that time. It was the template for how companies are structured today. This means that you have different departments that have a certain focus, such as product management, marketing department, sales department, development department, and quality assurance department. Taiichi Ohno. In the mid-50s, the Toyota production system became very famous. This man here is Taiichi Ohno, the inventor of the system. He developed the basic logistical methods of today, the Kanban system, and just-in-time production. The Japanese management concept Kaizen, which means for the better or change for the better, also goes back to him. Kaizen is about seeking continuous and infinite improvement. Regarding the Toyota production system, it can be said that every employee takes responsibility, and as soon as problems occur, the employees are asked to stop the entire system. Hirotaka Takeuchi and Ikujiro Nonaka. In 1986, there was a publication, the New Product Development Game. Furthermore, in 1986, Scrum appeared as a name for the first time. The authors Hirotaka Takeuchi and Ikujiro Nonaka studied how successful companies worked and found similarities. Similarities which they summarized under the name Scrum. This was not yet what is understood by Scrum today, but it was the first mention of the word. Ken Schwaber and Jeff Sutherland. In 1995, Ken Schwaber and Jeff Sutherland introduced Scrum as a framework. They thought about how to take what was written in 1986 and put it into a set of rules so that teams could work according to it and achieve similar success. Agile Manifesto. In 2001, a group of software developers signed the Agile Manifesto for software development. It originated in software development, but today it is much broader and is not only used as the basis for software developers, but for many other areas. Kanban. Successful evolutionary change for your technology company. In 2010, Mr. David J. Anderson introduced Kanban for IT organizations. Kanban has been around for a while, but to really use Kanban in a complex environment, Kanban needed an extension here and there. Nowadays, there are many different agile frameworks for scaling, such as working with many different teams on the same product as efficiently as possible. There are quite a few different certification bodies. There has been a lot of hype around it. It has been commercialized, but still a very powerful and very comprehensive tool. Here's your next question. Again, you have 15 seconds to answer the following question. The Scrum framework dates back to Time is over. The right answer is number 4, 1995. The definition of Agile Project Management. Agile Project Management is an iterative development methodology that values human communication and feedback, adapting to change and producing working results. On the left side, we see classic project management. In classic project management, which is also called waterfall, you always work sequentially with different departments on tasks. That means, for example, there is a department in the company for requirements and analysis, and there are experts in the department who look at, analyze, and plan customer requirements. When they are done with that, they hand over their results to another department or experts who then have to create a specification. They then look at how to specify this problem so that it can be implemented. These in turn then pass on documents to the development department, which has the task of converting what has been specified into a product, a service, or software. This is the implementation. Once the implementation is complete, the development department passes on to the quality department. This ensures that the software is as error-free as possible and checks whether the product product meets the specified criteria. After the activities are completed, it may go on to the marketing. If it has to be put on DVD, it goes to the pressing plant, or in the case of a service, it goes into a catalog. You go through these steps sequentially, and at the end a value is created. When it is then made available, the customer can use the product and make use of the service. However, if mistakes were made in the requirements and analysis, and you had a different understanding of the subject, then we end up with a product that no one can use. This whole process, from the initial requirements analysis to development, usually takes 2 to 3 years. At the handover points, shown here as arrows, documents are classically handed over, at which misunderstandings can happen. This is because everyone wants to make sure that everyone has done everything right. To the right, we see the same steps but in agile iterations. You can visualize both methods by eating a big cake. In waterfall, we eat the whole cake layer by layer, which is probably not so delicious, because only when we eat all the layers at once do we get a delicious taste. The delicious taste is lost forever once one layer has been eaten. There is no going back. In Agile, you eat the cake differently. You cut out a small piece at a time and don't care about the whole cake. Eating all the layers at once is now much easier with a fork and also tastes better. It is easier to plan how many pieces we eat and when. Boss, I think we are ready to move to the next stage. Great. Boss, there is a problem with the requirements. No worries. We will just climb back up and... Wait. Which one of you brought the ladder? In 1986, it became obvious that when it really comes down to it, the way things have been done up to now has some risks. If we spend 2 or 3 years developing something and end up with something that no one needs anymore, you can't go back to the beginning. Well illustrated here in the comic. Because complexity has increased massively in the last 20 years, we can't afford not to make any major changes to our products for several years. We must become faster. The advantage of agile methods is that we no longer rely on departments, but on a cross-functional team consisting of experts who can cover all the steps from the waterfall model. Taking the previously mentioned pie principle and applying it to this diagram, we cut a slice out of this pie. In Scrum, we now produce the product in short periods of time. For example, every 2 weeks, starting with the analysis and ending with the delivery. For this, we need different experts in the team. At the end of a sprint, we still don't have quite the big value, shown as the stars on the bottom. We can't do as much within 2 weeks as we can within a year. But we do have something small. We can then give our small results to somebody for approval, and who asks themselves, is this what I want? Is this going in the right direction? Or is this completely missing the point? We need that feedback. Remember the complex quadrant in the Cynefin framework. We do an experiment, see if it works, and then react to it. That is exactly this step, here shown as dashed rectangle. We do a requirement analysis, build something together, and get feedback. Depending on the feedback, adjustments are necessary. If an adjustment needs to be made, then we go to the next step. Hopefully, more added value has come out of it. From iteration to iteration, we get and create more value. Also thanks to the feedback. We may realize later that we have already done everything the client wanted. We can save this planned project time, which is colored green in the rectangle. It allows us to move on to the next product or client now. The contract design has to be adapted to this. There are agile contract models that enable a win-win situation, both for the customer and for the developing company. Let's continue with the Agile Manifesto. The people in the photo are the reason why you are dealing with agility today. Let's talk about the 4 agile values. Scrum and Kanban take into account or are concrete ideas on how to bring these values and principles to life. The Agile Manifesto is the basis. There are 4 pairs of values and 12 principles written down. Individuals and interactions over process and tools. It is important to know that just because process and tools is under the left-hand side, it does not mean that process and tools are no longer needed. They are still important and help us. In case of doubt or priority, individuals and interactions should be weighted higher than process and tools. That is, if we have a process that blocks us, hurts us, and is not goal-oriented, we pay attention to good interactions. So how can we work well together? As that creates real value. Processes are really just tools to describe good interactions. Working software over comprehensive documentation. In the Agile Manifesto, the term software because it was written by software developers. The term product would be better. There have been some discussions for years about whether this should be rewritten, so that it is more universally valid and doesn't scare off interested people. What matters is what should come out at the end. Something that creates value. Documentation is understood to cover two things. One is customer documentation, such as user manuals. Some of these are required by law. But what do we get out of it if there are things in the user manual that don't work? The other is that companies invest a lot of time and energy in doing internal documentation. They want to make sure that everything has been done as required by the contract. They can then say, "Here, we have documented everything, but the product does not work as required." There is no benefit to the client from internal documentation. These are the reasons why the focus must be on working software. This means, as in the previous case, documentation is an important part, but it should be appropriately present. Customer collaboration over contract negotiation. Of course, we need contracts, commitments, and legal certainty. However, it is worth much more if we work with the client at eye level. That means we talk to them, involve them, take their feedback seriously, and we show them intermediate results. This way, we don't miss the point. The client is satisfied and quickly gets more value. Maybe even intermediate results can be used productively. It doesn't help if at the end of a project you can say that the product doesn't meet the client's expectations, but the contract has been fulfilled. See the scope statement and statement of work. Responding to change over following a plan. Perhaps the most important point. Plans are important even in the agile environment. We should have a plan, but not stick stoically to the plan. If we see something changing to the right or left of us, if the customer gives us feedback like, "What you have planned doesn't help us," then we should react. So we adjust our plan. Remember, the Cunefin framework, when we are in a complex environment, we should regularly check, are we on the right track? Should ask for feedback and then react to it. These 4 agile values alone clearly show that they are made to let us be more effective in the complex environment. In contrast to the classical approaches we have used for years in the past. The 12 principles are: our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Customers are happier when they receive working software at regular intervals rather than waiting extended periods of time between releases. Welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. The ability to avoid delays when a requirement or feature request changes. Deliver working software frequently, from a couple of weeks to a couple of months, with a preference to the shorter timescale. Scrum accommodates this principle since the team operates in software sprints, or iterations that ensure regular delivery of working software. Business people and developers must work together daily throughout the project. Better decisions are made when the business and technical team are aligned. Build projects around motivated individuals. Give them the environment and support they need and trust them to get the job done. Motivated teams are more likely to deliver their best work than unhappy teams. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Communication is more successful when development teams are co-located. Working software is the primary measure of progress. Delivering functional software to the customer is the ultimate factor that measures progress. Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Teams establish a repeatable and maintainable speed at which they can deliver working software, and they repeat it with each release. Continuous attention to technical excellence and good design enhances agility. The right skills and good design ensures the team can maintain the pace, constantly improve the product, and sustain change. Simplicity, the art of maximizing the amount of work not done, is essential. Develop just enough to get the job done for right now. The best architectures, requirements, and designs emerge from self-organizing teams. Skilled and motivated team members who have decision-making power take ownership, communicate regularly with other team members, and share ideas that deliver quality products. At regular intervals, the team reflects on how to become more effective. then tunes and adjusts its behavior accordingly. Self-improvement, process improvement, advancing skills and techniques help team members work more efficiently. Let us take a look for a short moment on the Kanban board. Kanban comes from the Japanese and stands for signboard and billboard. What does Kanban look like in practice? In fact, this board is often referred to as such. If you talk about a real Kanban board, this is not one. This is more like a task board. It helps to make tasks visible. Kanban helps to reveal bottlenecks as well as to make the flow of work visible. The only flow we see here is that a task is either not started, it is in progress, or it is already done. If we were looking for a bottleneck here, it would very quickly be found in the In Progress column. There is no work in the To Do and Done columns. To speak of Kanban, we need to visualize the flow of work here. We can visualize the workflow by looking at it in more detail. The step In Progress could now be divided into development and verification. That would make it a bit more precise. We can refine the whole thing even further. Our workflow usually looks like this. We get a new task, we analyze and develop it. The component is integrated into what is already there. The whole thing has to go through quality assurance, has to be documented, and the last step is delivery. Now we have a process here which shows us which steps we have to take. In order to be able to speak of a Kanban board, we need clear rules about what the individual steps mean. For example, we need to define criteria so that something can go from to do to analysis. Up here we have a definition in the form of a document symbol of what all has to be present as a result in this work step so that it can be considered finished. Only then do we go to the next step. Then we have points from when we can commit to something or where the analysis and documentation is done by another team. From the green point above, we as a team say we are developing the whole thing, and from the blue point above, we hand over to the following team. The green point is called a commitment point, and the blue a delivery point. For visualization, we need to make the whole work visible. See the notes on the far left. Kanban boards have swim lanes, shown here as red lines. It is a horizontal distinction. We could have a swim lane for new features for bug fixes, and for prototypes. Swim lanes are optional. Furthermore, one can define different promises per swim lane. For example, one could promise a customer, "We will give you a bug fix within 3 days." Non-optional and very important are the work in progress limiters. They limit the amount of work that can be done in parallel for each step. In our example, this means that only 30 work packages may be open in the development column. No 31st may be added. This has two very important consequences. One is that the whole system changes from a push to a pull system. We can only ever pull something into a column if there is a free capacity. In other words, the maximum work in progress has not been reached. That helps regulate the bottleneck. We can adjust the work in progress limiters over the entire flow so that we get as even a flow as possible, which does not overload bottlenecks. Let's imagine that we are working on 8 tasks in parallel in development and they are finished at the same time. However, only a few can be closed because we have 2 people in quality assurance who do the testing. Those 2 people get buried with a huge mountain of work, and this is of course blocks the flow at some point. With work in progress limiters, we can control how much work is done in parallel and at what speed. The flow of work has the goal of completing what we have started as quickly as possible. This is above everything else in Kanban. The faster a task is completed, the faster we can take on the next tasks. Speed also gives us much more flexibility in how we prioritize and how that priority is then translated into the product. We need an understanding of when it is our turn to implement something and where our responsibility ends. There are metrics that are recorded. One is usually called cycle time, which means we can measure a period of time between any points. The moment we drag something into the development column, we start our stopwatch, and the moment it leaves verification, we stop our time measurement. We can have a cycle time between any points. Furthermore, there can be as many cycle times as we want. But there is also the lead time. It measures the total time a work package spends in the system. Lead time is the moment when the customer's request appears on a node up to the point at the very end where it has to be accepted, delivered, and no further work has to be done. Here you can see an example of a Kanban table from practice. Scrum will be the next point on our agenda. Does anyone know where the name Scrum comes from? The term comes from the sport of rugby and means crowd. The video first introduces rugby in terms of origin, pitch, team structure, and at the end, Scrum is explained.
Rugby is one of England's most popular sports and is played by people of all ages, shapes and sizes, male and female. This animation teaches you about the main laws of rugby so you can have more fun watching or playing this great game. You play rugby in a jersey, shorts and boots with studs, and you wear a mouth guard to protect your teeth. The ball is an oval shape and looks a bit like an egg. Because rugby originated in England, there are a lot of English expressions. There are two versions of rugby, rugby union and rugby league. This film is about rugby union, the most popular version of rugby around the world. The rugby pitch is about the same size as a football pitch. On the pitch, there are a number of lines. We start from the halfway line. From this line, the game is started or restarted after a score. Next is the 10-metre line. After the kick-off, the ball must cross this line. Then there is the 22-metre line. Next is the try line. Behind this line, you can score a try by touching the ball down. On the try line are the rugby posts, 2 vertical posts and a crossbar. The last line is the dead ball line and marks the end of the field. On the sides, you find the 5 metres line and the 15 metres line. During a line out, the players must stay between these lines. A game is 2 halves of 40 minutes and has a half-time break of about 10 minutes. A rugby team has 15 players. 8 of them are called the forwards. These guys form the scrum and line out and do the more heavy work. Next you have 7 players called the backs, and they do most of the fast running. The scrum half connects the forwards and the backs. The last man is the full back. Suppose you throw the ball forwards, or you drop the ball and it bounces forward. In both cases, the referee will decide that a scrum must be formed. A scrum is a restart after a foul where the ball travels forward from the hand. The forwards of both teams set in a specific formation and set against each other, like you can see in this view from above. Next, the scrum half will roll the ball straight into the middle of the scrum, and both teams are allowed to contest for the ball by pushing and using their feet after the ball has entered the scrum to move the ball backwards. While the ball is in the scrum, you are not allowed to touch it with your hands. When the ball comes out of the scrum, it is usually the scrum half who will pass it to one of the waiting players, and the next attack will start.
The photo is from 2015 from the Rugby World Cup match between New Zealand and Tonga. As shown in the photo, the team here is in a scrum for the ball. This was adopted by the authors in 1986 as a symbol of what is seen in teamwork. The teams put their heads together, are very close to each other, and they give all their strength to achieve their goal. A new play starts with a scrum after certain interruptions. They have 30 seconds to form a scrum. We call it time-boxed. Referees, a kind of scrum master, make sure that the rules are followed. Referees decide from which side the ball is thrown in. The rule is that the ball must come from outside the scrum, without delay and quick movement. The scrum starts as soon as the ball has left the hands. There is a definition of when scrum ends. This is one of the reasons why the term scrum has been borrowed. As in rugby, so at work. We need rules and agreements without which it doesn't work, or, in the worst case, makes working life difficult for everyone. Here, working agreements make conflict management easier for us. We should have them and keep them visible. As a participant on this team, I agree and acknowledge that I'm committed to the team's objectives and goals. I respect other people's opinions even when they contradict or conflict with mine. If we cannot reach an agreement, I will seek and support a majority decision. I will avoid at all times preventing my team from moving forward. Whether the team's decision agrees with mine or not, I will do my best to implement it. When we talk about Scrum, we refer to the Scrum Guide, which is considered the official rules of Scrum. It is currently offered in 48 languages. The document is not particularly long. It has only 14 pages. The latest version is from November 2020. The authors wrote in their book, "We wrote the first version of the Scrum Guide in 2010 to help people around the world understand Scrum." The Scrum Guide contains the definition of Scrum. Each element of the framework serves a specific purpose that is essential to the overall value and results realized with Scrum. Changing the core design or ideas of Scrum, leaving out elements, or not following the rules of Scrum covers up problems and limits the usefulness of Scrum, possibly even rendering it useless. The elements defined in this framework are designed to leave a lot of freedom, but also to allow them to work together. Each role has a clear responsibility. Each event has a clear goal, and together they fit together wonderfully. That's not to say that's the only way to do it. You should always Look at the context like what way of working fits. If you make adjustments and leave out certain things that are required in the Scrum Guide, then that can be good and work. But then you shouldn't call it Scrum. Also, against the background that companies have tried to introduce Scrum but have not understood how it works. They left out important aspects and then wondered why it didn't work. To the outside world, they then communicate. Scrum doesn't work for us. If you take a closer look, you see that unfortunately, what they did was not Scrum. Maybe they left out the product owner and let everyone have a say. It can work, but it doesn't have to. Everything starts with a vision or idea that you believe you can turn into a good product. It is worth putting work into it and earning money with it. The things that have to be implemented to get closer to this version are collected in the product backlog. That is, a list is created in which all the necessary work is included. These tasks in the product backlog are prioritized. The work that is assumed to be the most important is at the top. The further down you go, the lower the value of a work package. In Scrum, there is one role that is responsible for the backlog. This is the product owner. This role belongs to the activity of product management, but it looks different from classical product management. The product owner carries the complete responsibility for the implementation of the product. It is also said that the PO is something like an owner in his/her own company and has the responsibility but also the authority to prioritize, to decide what the team works on and what brings the most business value. The PO does not have to do all this alone. An important task of the PO is stakeholder management. Stakeholders are interest groups, meaning people who have an interest in what is being created, who are in the same company, management, other teams, and that can also be actual customers. They give their input to the PO. So the PO has to listen to the stakeholders and come up with a good product backlog. That means adjusting priorities, taking new requirements, and bringing them into the product backlog. Then there are the developers. Developer can be understood purely in terms of software development. What the authors of the Scrum Guide mean are the people who implement the product. These people have all the necessary skills to do this. In software development, they are software developers, analysts, testers, technical writers, and so on. They all have the technical implementation responsibility, and are supposed to work together as a team with joint responsibility to transform what is in the product backlog into a product, into something that can really be used. You don't have special titles and roles because in Scrum you want people to work as a team and also take responsibility as a team. Let us take an example from software development. If we have software developers and software testers in a team, and at the end there is still one test missing to mark a task as done, nobody points the finger at the testers. It is a team responsibility. People have to support each other. Scrum teams are distant or isolated from the stakeholders, not in the sense that they don't get information anymore, but in such a way that they are not overloaded with different tasks from different people. Managers can be in the stakeholder group, but no longer go to the team and say to the developers, "Hey, I need this or that quickly." There are clear guidelines on how work packages are brought to the team, namely always via the product backlog. The stakeholders explain to the product owner what they want and why it is important, and the product owner will then prioritize it upwards in the product backlog. After that, the work comes to the team, so that the team knows what to work on. They create a sprint backlog together with the product owner and meet for a sprint planning event. Event because meetings have a negative touch, because they cost time and are badly organized. In the sense of Scrum, events mean that people come together and each event has a time box, which means a maximum time that it is allowed to last. When this time has expired, the event is ended. The next steps are taken with the result that has been achieved up to that point. If the result is achieved earlier, the event is also ended earlier. Each sprint starts with a sprint planning event, in which the Scrum team decides together with the product owner what we want to implement together in the next sprint. You define a sprint goal, which is usually formulated abstractly, and then you select from the product backlog which functionalities have to be implemented to achieve this goal. You go through the product backlog from top to bottom. The sprint goal should be derived from the product backlog. Neither the product owner, a manager, nor a stakeholder tells the team what it has to implement, but the team says how long it needs to complete the task from top to bottom in a sprint. These items go into the sprint backlog until they say we can do it by then and we can't do anything else. The team itself says and decides how much work it will take into the sprint. Then the Scrum team goes off with this plan and this backlog which they have worked out. You know the Cynefin framework. The trick that Scrum does to absorb complexity is the following. We are in a complex environment. Scrum is suitable for new developments because these are definitely complex. For bug fixes, where we know exactly what we are doing, the overhead of all the roles and events is probably too high to justify it. This means that in a complex environment, Scrum has many advantages, but in a complicated environment, we are probably shooting at sparrows with cannons. But if we are now in a complex environment, hence the example with software development, for instance, we are doing new developments, new product functionalities, then we are probably in a complex environment. Scrum is worth it there. For a sprint duration, which should be less than 4 weeks, we make certain things as assumptions. We know that in a complex environment, we should always experiment, notice, and react. Scrum says we break that up a bit. Our experiment now, we make it a bit bigger and encapsulate that. That means we behave as if we had understood exactly what the customer wants. We now freeze their requirement. So it is no longer a complex problem, but a complicated problem. We can analyze it classically, plan it, and say what we want to deliver in the end. Since we are actually still in a complex environment, we need feedback loops. In other words, the higher level environment is complex, but individual tasks can be transferred into the complicated over certain periods of time. That is what you do in a sprint planning. Here we say we think we know, freeze those assumptions, and take them as true. Well, after a sprint, we look to see if we were right. In the worst case, our assumptions are wrong assumptions, so we have developed past the point. 4 weeks is the maximum that can be tolerated in such cases. In very fast-paced environments, there are teams that do daily sprints, which means they go through the cycle we see here every day. Every 24 hours, the team comes together and does a daily scrum. It is also called a daily stand-up. You come together for a maximum of 15 minutes. This means that there is a fixed time box here as well. The goal is not to make a status report. As a reminder, we agreed on a sprint goal in sprint planning. Therefore, every day we look at where we stand in relation to the sprint goal. If we are not likely to reach it, we have to make adjustments. If we have problems, we ask ourselves how we can set ourselves up in the next 24 hours until the next daily Scrum, so that we can work as effectively as possible. It can happen that a colleague drops out at short notice. The team must be able to react to this. A daily Scrum helps us to replan how we want to approach the next working day. Classically, it should take place at the beginning of the working day. No other demands should really be made on the team for the duration of the sprint. They need to be able to work focused on the sprint content. During sprint planning, the abstract and overall sprint goal is defined. If this sprint goal is endangered because it no longer makes sense, then the sprint should be terminated. In other words, the product owner stops the sprint. A retrospective is done to prevent this from happening again. Then a new sprint planning is done. A new sprint goal is defined to go into the next sprint. There are cases where, for example, an urgent bug fix needs to be included. For this reason, the sprint must not be terminated. It must be evaluated whether the sprint goal still makes sense. Individual work packages in the sprint backlog can be exchanged for work packages of the same size. In practice, this often happens. It should not be the rule and should be the exception. The goal in Scrum is to have as few changes as possible in a sprint. That is the reason to plan smaller sprints. If we plan 4 weeks, we can only adjust our course every 4 weeks. Bug fixes are always a challenge in the Scrum environment. They cannot be planned because they occur spontaneously. This is more problematic in a 4-week sprint than in a 2-week sprint. At the end of a sprint, hopefully a product increment, meaning a potentially deliverable product, has been created. Potentially deliverable does not mean that it has to be delivered. It should meet certain quality criteria and somehow generate added value. Product increment means that something has been built that is integrated into what we already had before. What some teams have not yet understood is that if, for example, the test step is missing from the definition of done, then the product increment is not potentially deliverable. This is because it is not clear whether quality criteria have been met or whether it breaks anything. The product increment is presented in the sprint review. Now we come to the point that sets the whole thing up for complexity again. Our stakeholders come and try out this product increment and give their feedback back. We notice the complex environment because we did an experiment for 2 weeks. The stakeholders tell us what the outcome is from the experiment. Was it good? Was it bad? Do we need to adjust something? Then we react to that. In the sprint review, you do that together with the customer. Remember back to the Agile Manifesto at the point, collaborate with the customer about contracts, and respond to change about following a plan. We decide with the customer what the possible steps are in the next sprint. In practice, this means that the customer gives his/her feedback to the product owner, who then adjusts the product backlog. After the review, the team goes into the sprint retrospective. This means that we get feedback on what we have delivered as a team. We also get feedback on how we delivered it. How did we work together? What can we improve? The Scrum Master moderates the sprint retrospective. Furthermore, the Scrum Master makes sure that improvements come out of it. Every sprint, the team thinks about which improvements could help to become even more effective. Then they decide on 1 or 2 improvements which are taken over into the sprint backlog. You have 1 improvement in every sprint. The Scrum Master is a completely new role which did not exist in the classical environment. Of course, there are also costs involved. Good Scrum Masters are expensive. For a company that is under pressure right now, you have to consider whether you are paying a person who is not contributing to the value creation. In other words, Scrum Masters don't work on the product. This role has to be profitable somehow, which in turn means that the Scrum Master has important tasks. One task is to help the team improve itself and become more effective. If the Scrum Master works with the developers to bring out small improvements every sprint, the hope is that the investment in a Scrum Master will pay off, so to speak, at some point. The team develops further, becomes more and more capable, and better and better. Changes to the product backlog can always result from both events, review and retrospective. The backlog is a living document into which new insights are added. The product backlog always contains what can create the most value. This is roughly a cycle in Scrum. So once we have gone through a sprint, now it starts all over again. We have an adjusted product backlog, do sprint planning again, go into the next sprint, and deliver at the end of the sprint. On and on like that, on the condition that the team can work calmly and with focus. A quick word about the term sprint. It seems a bit misleading because the term is also used in marathons. It should be possible to keep up the pace in the long run. The team should not be overburdened, but it should be able to do more over time. Not because they work harder or over time, but through retrospectives. They learn more about their own processes to work smarter and find better ways to work together. This makes them more and more effective. Here the next question. You have 15 seconds again. What is not a Scrum event? Time is over. Number 2, daily retro is the correct answer. At this point, I would like to give you a short hint. On RetroMod, you can find examples of how to build a creative retrospective. The goal is to expand creative thinking and break out of the usual thinking frames to think creatively about improvements. To do this, you have to think beyond the known. You also get an idea on this page of what a retrospective could be. Time for a short coffee break. Donald says, "Make Agile great again." Scrum's artifacts represent work or value. They are designed to maximize transparency of key information. Thus, everyone inspecting them has the same basis for adaptation. Each artifact contains a commitment to ensure it provides information that enhances transparency and focus against which progress can be measured. The product backlog is an emergent ordered list of what is needed to improve a single source of work undertaken by the Scrum team. Product backlog items that can be done by the Scrum team within one sprint are deemed ready for selection in a sprint planning event. They usually acquire this degree of transparency after refining activities. Product backlog refinement is the act of breaking down and further defining product backlog items into smaller, more precise items. This is an ongoing activity to add details such as a description, order, and size. Attributes often vary with the domain of work. The developers who will be doing the work are responsible for the sizing. The product owner may influence the developers by helping them understand and select trade-offs. The product goal describes a future state of the product which can serve as a target for the Scrum team to plan against. The product goal is in the product backlog. The rest of the product backlog emerges to define what will fulfill the product goal. A product is a vehicle to deliver value. It has a clear boundary, known stakeholders, well-defined users or customers. A product could be a service, a physical product, or something more abstract. The product goal is the long-term objective for the Scrum team. The objective before taking on the next. The sprint backlog is composed of the sprint goal, the set of product backlog items selected for the sprint, as well as an actionable plan for delivering the increment. The sprint backlog is a plan by and for the developers. It is a highly visible, real-time picture of the work that the developers plan to accomplish during the sprint in order to achieve the sprint goal. Consequently, the sprint backlog is updated throughout the sprint as more is learned. It should have enough detail that they can inspect their progress in the daily Scrum. The sprint goal is the single objective for the sprint. Although the sprint goal is a commitment by the developers, it provides flexibility in terms of the exact work needed to achieve it. The sprint goal also creates coherence and focus, encouraging the Scrum team to work together rather than on separate initiatives. The sprint goal is created during the sprint planning event and then added to the sprint backlog. As the developers work during the sprint, they keep the sprint goal in mind. If the work turns out to be different than they expected, they collaborate with the product owner to negotiate the scope of the sprint backlog within the sprint without affecting the sprint goal. An increment is a concrete stepping stone toward the product goal. Each increment is additive to all prior increments and thoroughly verified, ensuring that all increments work together. In order to provide value, the increment must be usable. Multiple increments may be created within a sprint. The sum of the increments is presented at the sprint review, thus supporting empiricism. However, an increment may be delivered to stakeholders prior to the end of the sprint. The sprint review should never be considered a gate to releasing value. Work cannot be considered part of an increment unless it meets the definition of done. The definition of done is a formal description of the state of the increment when it meets the quality measures required for the product. The moment a product backlog item meets the definition of done, an increment is born. The definition of done creates transparency by providing everyone a shared understanding of what work was completed as part of the increment. If a product backlog item does not meet the definition of done, it cannot be released or even presented at the sprint review. Instead, it returns to the product backlog for future consideration. If the definition of done for an increment is part of the standards of the organization, all Scrum teams must follow it as a minimum. If it is not an organizational standard, the Scrum team must create a definition of done appropriate for the product. The developers are required to conform to the definition of done. If there are multiple Scrum teams working together on a product, they must mutually define and comply with the same definition of done. The product backlog is an important part of Scrum. In business administration, we know the term customer orientation. The backlog as well as customer orientation both include the regular systematic recording and analysis of the wishes, needs, and expectations of the customers as well as their implementation. Here is a Jira example from practice. The backlog is sorted according to certain criteria. What is at the top is most important, and the further down, the less important it is. You can also categorize by categories the epics. The stories from the backlog are taken into the sprint backlog in sprint planning. Common tools are Jira and Azure DevOps. Let's talk about the product backlog refinement. Purpose: streamline sprint planning. If done well, sprint planning time should be cut in half. Make user stories immediately actionable. Gives incubation time for ideas before the team has to commit to the sprint. Who? The whole team. Invite stakeholders as necessary. When? A few days before sprint planning. How long? 2 hours per sprint. Activities during the product backlog refinement. Revisit the 3 C's. Card conversation confirmation. Add new stories. Remove stories that are no longer relevant. Estimate the effort of the highest priority stories. Use planning poker. Do team estimation. Split existing stories by use case, by simple versus complex, by acceptance criteria. Define acceptance criteria at a finer level of granularity. Running effective product backlog refinement sessions. Have a clear goal in mind. Here's the list of the user stories I would like us to focus on. Keep the energy level high by contributing ideas, mockups, customer insights, innovation games, and story maps. Take control of the meeting. Avoid too many "what do you guys think" statements. gain full cooperation of Scrum Master to keep the conversation going, to keep a positive and productive atmosphere. And at last, keep the meeting under 2 hours. The sprint backlog is similar to the product backlog, but it is a subset of the product backlog that is determined by the team. The team decides how much goes into the sprint backlog, and it belongs to the team. It is what the team believes they can deliver. Unfortunately, there are also obstacles. Every now and then, the team may encounter obstacles that prevent or delay the execution of work. These should be made visible and removed. If the team cannot solve them themselves, then the Scrum Master comes into play. Scrum Masters have the task of making this visible at a higher level and ensuring that these impediments are removed. To avoid misunderstandings, the Scrum Master is not the one who has to fix all the impediments, but by definition, they have the responsibility that they are fixed by someone. Now, let us look at the 3 roles. We have the product owner, who is responsible for the product backlog. This is the person who is responsible for the results. It happens that a product owner works with several teams. Not every team needs a product owner, but every product needs a product owner. There are cases where the product owner role is split up. So there is a product owner called the Chief PO. This person works more on a strategic level. But the product owners for teams have less authority and responsibility than the Chief PO. There is the possibility of scalability. Responsibility comparison, product manager versus product owner. When we talk about the product owner, we may also think about the product manager, and we may wonder how to separate them. When we think about roles and what they consist of, areas like focus, responsibilities, ownership, and metrics to measure success come to mind. But there are also roles and responsibilities on both sides that have no counterpart on the other. It is not always easy to clearly assign certain characteristics to both roles. Therefore, the table here should only be understood as an approach. Ultimately, each company defines for itself how these roles are structured. The overlap between product manager and product owner. Where there are similar roles with partial overlaps, as seen on the slide before, there can also be conflicts. The advice is generally to divide the points mentioned so far according to strengths and weaknesses. Assigning all the responsibilities and tasks of a product manager and product owner to a single person can overburden that person. so that this person can only take care of what is absolutely urgent. So it can happen that medium-term customer wishes are fulfilled, but long-term customer wishes fall by the wayside. Let us first take a look at what areas a product manager and a product owner share. Vision and roadmap, release planning are familiar, so I won't go into them further. Persona represent a prototype for a group of users with concrete characteristics and a concrete usage behavior. Other points are the definition of needs and features, customer advocates in development, defect management, and positioning. The greatest potential for conflict is the responsibility for roadmap and product vision, as well as who is in contact with the customers. The team. Developers does not mean software developers, but it generally means everyone who is needed in a cross-functional team to deliver a product. They all share responsibility for the result. In this context, one speaks of T-shaped skills. As a rule, one aims for T-shaped skills. Here is a football analogy. In football, we have strikers, midfielders, defenders, and a goalkeeper. They should be team players. That means that if we play against a very strong opponent, my strikers may have to help out at the back to defend. On the other hand, if we absolutely have to score a goal, then the defenders also have to go forward and try to score a goal. That is how it is in team sports, where T-shaped skills are also desirable. The concept of T-shaped skills or T-shaped persons is a metaphor used in job recruitment to describe the abilities of persons in the workforce. The vertical bar on the letter T represents the depth of related skills and expertise in a single field, whereas the horizontal bar is the ability to collaborate across disciplines with experts in other areas and apply knowledge in areas of expertise other than one's own. Classically, we have experts. They have the I-shaped profile. I as in a vertical bar. They know a tool, technology, method, etc. well in detail and depth. So a software developer can write code well, and a software tester can test well. We want a T-shaped profile with expert knowledge in depth, but we also want something that goes in breadth. So software developers can learn from testers how to support them to do good software testing. For example, a software tester could learn from the analyst and help to create good specifications. A common misunderstanding in practice is that people think everyone has to be able to do everything, which is utopian and not needed. As a reminder, The strikers have to be able to help out in defense. For our team, this means that we don't have to become experts in testing, but we should be able to support the testers with their topics in order to achieve the goal together as a team. Here are the responsibilities of the team. I won't go into the details now. The last role is the Scrum Master, one of the most underrated roles in Scrum. He/she is considered exotic. He/she does not work on the subject. In practice, it often happens that someone takes on a double role. That is, 50% of the time someone plays the Scrum Master and the other half he or she plays a developer role. This is often the case in practice. Actually, this role is meant to be 100%, meaning full time. But it is relatively rare in practice. Most full-time Scrum Masters usually supervise 2 teams. More and more attention is being paid to the skills and training of Scrum Masters. The Scrum Master wears many hats. He/she is a coach for the team, both as a group and individuals. He/she is a conflict resolver for the team, which means a mediator role. He/she is also a support for the team, for example by finding new ways of working for the team, how to deal with pair programming, or with test-driven development. He/she is also the process owner and has to teach the team how Scrum works and make sure it is followed. He/she also has to facilitate meetings. He/she has to help resolve impediments. He/she has 3 tasks, so he/she has to be a coach for the product owner. That means the Scrum Master should also understand how a product owner maintains his/her backlog, how a product owner can prioritize. He/she should have methodological knowledge and be able to support. Finally, the Scrum Master should have an effect on the organization, meaning what Kanban does in situations with bottlenecks that lead to changes. Is said here in Scrum that the Scrum Master should take on the role of a change agent. That means that the Scrum Master should work in the organization, bring changes into the organization, coach the organization to become better and more agile. This is such a huge bundle that there are hardly any Scrum Masters who know all these skills so deeply. There, too, we need a T profile. That is how the Scrum Master is meant to be. In practice, there are some companies that see the Scrum Master as a kindergarten teacher and a meeting organizer. We see the Scrum Master, product owner, and team as having leadership responsibility. The Scrum Master has the responsibility to anchor the process and develop the team. The Product Owner has the responsibility to define the what, meaning what we implement and what we work on. The team is responsible for the how, meaning what the solution looks like and how it is implemented. These issues are the responsibility of the team. In this way, the classic leadership role, as found in classic environments, is divided up. In the Agile environment, this is called the balance of power. In classic environments, we have one person who carries all these responsibilities, who is also the line manager, who therefore has authority to issue directives, who specifies what is to be done, because he or she is also responsible for the project, who also says how work is to be done, specifies processes and solutions. This is divided into 4 different roles. The manager in the sense of line manager, the product owner for what, the Scrum Master for the excellence, the further development and the process, as well as the team for the contents and the solutions and how it should be implemented. It is an advantage if the Scrum Master knows a bit. He/she can do his/her job better if he/she understands what the team is dealing with. If he/she can understand the problems because he/she has also worked in the field himself/herself. There are 2 directions Scrum Masters come from. One is technical, and the other is where Scrum Masters come from, social and psychological backgrounds. Rugby is a team sport that requires all 15 players to participate in both offense and defense. Thus, all rugby players must learn the basic skills of catching and passing the ball, running with the ball, tackling, and rucking. However, some areas of the match, like restarting play, following a stoppage, or counter-attacking from a deep kick, require specialized training and skills. Generally speaking, players will learn and practice these specialized skills as either a forward unit or a back unit. Here is a comparison table between Scrum and Kanban. Our next point of the agenda is the customer in focus. Here comes the topic of user stories. In Scrum, in contrast to classic requirements engineering or requirements management, we try to look at things from the customer's point of view. The advantage of a Scrum team, which is an interdisciplinary, cross-functional team is that we bring together different points of view. In classical requirements management, we usually have one person who defines a solution. So, one point of view. In the Agile environment, we want to bring in many different perspectives and expertise as a team to find a solution. This solution is better than the smartest thing the best of the group could have brought. We build on each other. To achieve this, we have user stories that describe the problem, or, in other words, give a desired direction for the solution. The ConExtra format is often used for this. This is named after the company that first used and published it. The format is written like this. As, then you specify a role. Can I, some function that I would like to have in the future, so that, and describe the added value. The role can be a person, a device, or a system. Here is an example that some of you may know. As a movie fan, I want to be able to watch movies at home via streaming services, so that I can invite and watch with my friends. Another example. A tennis player has to hit the ball over the net with something to score points. There is no solution for the tennis player yet, but the user story specifies who needs what. We can now start collecting information about what makes a tennis player. Then we can think about a solution. ConExtra format examples. As a consumer, I want to be able to see my daily energy usage so that I can lower my energy costs and usage. As an administrator, I can set the consumer's password security rules so that users are required to create and retain secure passwords, keeping the system secure. As a utility marketing director, I can present users with new pricing programs so that they are more likely to continue purchasing energy from me. As a technical support member, I want the user to receive a consistent and clear message anywhere in the application so that they can fix the issue without calling support. These 3 C's pictured here are what we do when we think about a solution together. 3C stands for card, conversation, confirmation. The product owner comes to the team with a user story on a card. There is no solution yet. Now you start a joint conversation and think about what the solution could look like. Then the acceptance criteria are defined in the backlog. A user story with acceptance criteria can potentially go into the next sprint backlog. The product backlog has various properties, so it must be detailed among other things. The higher up in the backlog, the more detailed the user stories become. They must be estimated, which means they must have an approximate size. If the product owner puts a sequence in the product backlog, it is known what value a user story brings. What is unknown is what must be invested to achieve this value. The product owner is still missing important information. 1. Estimates the user stories that are at the top of the list. The estimate shows whether the user stories are small enough. After all, they should fit into sprints. They may have to be cut even smaller. The lower down in the backlog, the bigger and larger the user stories may be. These only become important when they are to be dragged into one of the next sprints. Emergent means it changes through each sprint. We learn something new. We can add new user stories, take them out, and of course adapt them. The product backlog is prioritized. What is on top has the most value. The whole thing can be nicely remembered by the English acronym D. Work for the team should only come from the product backlog. When someone from outside the team wants something, that person goes to the product owner. This way, the product owner can prioritize better than if someone goes directly to the team. The product owner knows the relationships between the user stories in the product backlog. Only if everything goes through the product owner can he or she make a good decision. So, whether a user story is really important and someone must deal with it, or whether it is not rather to be seen lower down in the product backlog. The product owner is responsible for the content, availability, and prioritization of the backlog. Invest in a good story. The second acronym are the INVEST criteria. User stories should be independent of each other. When we write user stories, we open up a solution space, so we can negotiate what the solution looks like. It must bring value and be estimable. Furthermore, it must fit into a sprint. It should be testable, which does not mean a product test by an influencer. Let's go back to our example with the tennis player. After the first sprint, the tennis player gets a baseball bat from us. He can now use it to try to hit a tennis ball over the net. Our solution can be tested in practice. User story breakdown. When we take a closer look at a backlog item during product backlog refinement and sprint planning, we will come across two categories. Each of these categories has its own characteristics, which we deal with differently. A complex problem, which despite analysis we do not understand and therefore cannot estimate, then we work with technical and functional spikes. A compound problem, which is composed of many aspects around one topic, can be too big and therefore not fit into a sprint. There are different ways to cut large backlog items into smaller pieces. Let us see what makes the definition of spikes. Spikes are an invention of extreme programming. They are a special type of user story. With them, we can gain the necessary insights, reduce the risk of a technical approach, better understand a requirement, or increase the reliability of an estimate. A spike is time-boxed. Maximum like the sprint it is included in. At the end of a sprint, it is evaluated whether the spike is done or not done, just like any other common user story. A spike is a great way to minimize risk early on, gather feedback, and develop an understanding of the complexity of an upcoming product backlog item. When should we use a spike? Sometimes we are not sure if we can complete the story due to some potential blockers, and probably cannot even estimate the story. We can consider a spike as an investment for a product owner. The spike helps to figure out what needs to be built and how we are going to build it. The product owner assigns a bit of capacity to the spike even before the story needs to be delivered. This way we know what needs to be done when the story comes into a sprint. Here are examples of when spikes can be used. We may not have knowledge of a new technology. Spikes can be used for basic research to ensure proof of concept for the new technology. A user story needs to be implemented using a third-party library with an API that is poorly written and documented. This user story may contain significant technical risk. We may need to do some experimentation or prototyping to gain confidence in the technology solution. Acceptance criteria for spikes. Like any other ordinary user story, they must meet certain criteria to be given the status of done. Ensure that by doing so, the spike is estimable, demonstrable, and acceptable. Estimable. Spikes are stored in the backlog like ordinary user stories, made estimable and sized to fit into a sprint. The result of a spike are different from a user story because they usually produce information, not working code. A spike can lead to a decision, a prototype, a storyboard, a proof of concept, or some other partial solution to support the end result. In either case, the spike should produce just the information to remove the uncertainty. The hidden user stories are identified and can be sized. Spikes are valued as in-sprint tasks. The duration of the spike should be spent researching and developing a thing that can be delivered. This thing can be a working piece of software, a workflow, documentation, etc. Ultimately, the value of the spike is a direction or redirection of a feature. If the team values a spike at 4 hours, then only 4 hours may be spent on research or development. Prototypes, proofs of concept, and wireframes all fall under the classification of spikes. Demonstrable. The outcome of a spike is demonstrable to the team. Research and architectural efforts become visible. Collective accountability is established for the key decisions made. Acceptable. Like any other user story, spikes are accepted by the product owner if the acceptance criteria for the spike are met. The technical spike is more commonly used. It is used to evaluate the impact of a new technology on the current implementation. We need to try a new technology to gain more confidence for a desired approach. Example of a technical spike. How long does it take to update the display at the client side for their usage patterns, determine communication requirements and bandwidth, and decide whether to push or pull the data? A functional spike is used whenever there is significant uncertainty about how a user might interact with the system. It is often evaluated through prototypes, be it user interfaces, mock-ups, wireframes, page flows, or other techniques that are best suited to get feedback from the client or stakeholders. Example of a functional spike. Prototype a histogram on the web portal and get user feedback on display size, style, and charting. Here we see an overview of possible breakdown criteria. Instead of breakdown, one also often speaks of the story split. I will go into these in detail in the following. Breakdown by workflow steps. Here on the left, we see a very large product backlog item. As it does not fit into our sprint, we identify specific steps that the user takes to accomplish a workflow, then implement the workflow in increments. As a utility company, I want to update and publish pricing programs to my customer so that I can publish pricing programs to the customer's in-home display. I can publish the pricing table to a customer's smart thermostat. I can send the message to the customer's web portal. Breakdown by business rule variations. Business rule variations often provide a straightforward splitting scheme. As a utility, I can sort customers by different demographics. Sort by zip code, sort by home demographics, sort by energy consumption. Breakdown by major effort. Split into several parts, with the first requiring the most effort. Adding more functionality can be done later on. As a utility, I want to be able to select, change my pricing program with my utility through my web portal. I want to use time of use pricing. I want to prepay for my energy. I want to enroll in critical peak pricing. Breakdown by simple, complex. Simplify. What is the simplest version that can possibly work? As a user, I basically want a fixed price, but I also want to be notified of critical peak pricing events so that I can respond to the time and the duration of the critical peak pricing event. I can respond to emergency events. Breakdown by operations. Split by type of operation. Example: create, read, update, delete. As a user, I can manage my account. I can sign up for an account. I can edit my account settings. I can add more devices to my account. I can cancel my account. Breakdown by use case scenarios. If use cases are used to represent complex interaction, the story can be split via the individual scenarios. As a user, I can enroll in the energy savings program through a retail distributor. Use case story number 1. Happy path. Notify utility that consumer has equipment. Use case story number 2. Utility provisions equipment and data, notifies consumer. Use case story number 3. Alternate scenario. Handle data validation errors. Messaging pattern. Without the right number of people in the right roles, bottlenecks will severely limit velocity. Therefore, the number of people at the enterprise must be roughly in balance. If the ratio is unbalanced, the whole system will spend much of its time waiting for definition, clarification, and acceptance. Product manager. He/she works with up to 2 to maximum 4 POs and N customers. Product owner. He/she is responsible for 1 to maximum 2 Agile teams. A product owner is assigned to 1 product manager. Agile teams. They have one dedicated PO. And now we will learn something about Agile estimates. I need a budget estimate for my project, but I don't have a scope or a design for it yet. Okay, my estimate is $3,583,729. You don't know anything about my project. That makes two of us. Relative estimates. The issue of estimation is important and different in the Agile environment than in the classical ones. In the Agile environment, we use relative estimates and not units of time. So we don't estimate with 3 days or 5 hours. Elements of a story point. Before we go deeper and deeper into story points, let us take a quick look at what story points can consist of. We have difficulty, complexity. Please do not confuse complexity with difficulty. These are two terms with different meanings. Let us continue. Business value, potential risks, amount of work, effort, external and/or internal dependencies, uncertainty. As you can see, this list already includes a lot of factors that play into our story points. Not all of them have to or can be taken into account. The best way here is probably the middle way. So find the way that suits your project. When we ask, how far is it to the station? And get the answer, about 15 minutes from here. It makes a difference whether we are traveling fast or slow. The one who travels faster will reach the station sooner, whereas the one who travels slower won't even make it halfway. This problem also arises in a cross-functional team, where different areas of expertise come together and where there are different levels of previous knowledge. If we ask someone, how long will it take you to do this task? Then the experienced person says, I solved that in half an hour. And the less experienced person says, I need a week for that. The task is always the same. To the question, how far is it to the station? You can answer, for example, about 2 kilometers from here. Kilometers are independent of how fast someone can walk. Moreover, we all have the same understanding of kilometers. This is exactly what we try to aim for in the Agile environment. We no longer ask for times because the teams are going at different speeds. If we want to estimate something, we need the same understanding. Traveling by car. After the simple example with time and kilometers, here is another example to deepen our understanding. The task we are given is to travel a certain number of kilometers. A car can carry 40, 45, 50 or more liters of fuel. If we now fill up 20 liters for car A and also 20 liters for car B, then the costs at the petrol station are the same. Unfortunately, we cannot link the tank volume with the distance. We will soon find out why this is so. How much time does it take to complete the task? This rough road here on the left will have a different number of story points based on complexity and risk than the road here on the right. The time of execution applied with a resource is also different. We have three resources in our example: an auto rickshaw, also called a tuk-tuk, a tractor, and a sports car. The auto rickshaw takes 2 hours on the left and only 40 minutes on the right for the road conditions here. A tractor, because of its nature, needs only 30 minutes on both road conditions at the same speed. Due to the low ground clearance, the sports car can only reach its destination in 2.5 hours under the left-hand road conditions. On the right, on the other hand, the sports car can complete the distance in 5 minutes. The time needed depends on which of the three resources we take for our task. In addition, other factors that influence the time required must also be taken into account. More about this now. Briefly remember the previous slide about what makes up story points. So complexity, difficulty, business value, risks, etc. We apply that in the slightly expanded scenario. As we heard before, our task is to travel. We cannot possibly know all the circumstances of the journey before we set off. Also, parts of the road will be unknown factors to us. What we can know before we leave, however, is which vehicles will be available to us. But we also have to consider the following. The road conditions could be like the picture here on the left: uneven, poorly constructed, muddy, and curvy. Or like here on the right: always straight ahead, paved, even, and clear. You can't directly say it takes longer on the road on the left than on the road on the right. An experienced driver might only take 10 minutes on a bumpy road. A novice driver might take 1 hour on a smooth road like the one on the right. Our progress on the two roads could depend on rain or snow. These are not only dependencies, at the same time they are also risks. The complexity also increases when we have to put snow chains on the vehicle tires and drive with them for the first time in our lives. Icy roads and aquaplaning present us with enormous challenges. Tough traffic jams can slow down progress, and sudden jams or jams behind curves can be a threat. Pedestrians and cyclists on the roadway can also slow us down. There are different vehicle manufacturers with different technologies and engines. Tire quality and pressure play into fuel economy and safety. Different body styles come with weight differences, aerodynamics, and fuel tank capacity. During the day, we naturally see better and can foresee the course of a road. At night, we probably drive slower because we recognize curves later. Last but not least, our driving style, sporty or predictive, also has a significant influence on fuel consumption. Now, it should be clear that estimating with time values is less meaningful. Now you have a concrete idea of what story points are. I will try to explain to you how to get the story points in a real project. Imagine we have a backlog with different user stories in it. We have a rough estimate of how much work they mean. Now we could sort them into 3 different sized buckets. In one, where everything small goes in, a middle one, and a very large one. Probably this is not yet fine granular enough, so we divide these buckets even further. So we have the small bucket, and inside it again, small, medium, and large. These yellow rectangles here symbolize our backlog items. Now we can start assigning numbers to these backlog items. The numbers are derived from the 9 differentiations. Here we have an approximated Fibonacci sequence. In Fibonacci, the following number is the addition of the first. So 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 8 is 13. Actually, 21 should be written here instead of 20. From here on, it is only approximate, and the higher the number, the more vague our estimates. If we have relatively large work packages in the product backlog, which we have not yet cut smaller, then there is so much uncertainty that the details do not matter. There is simply more uncertainty. The challenge now is to calculate the velocity of the team from the numbers. This can be used to determine how many story points can be completed on average by the team per sprint. This is determined over several sprints, and later you can say, my team manages 100 story points per sprint. This allows us to predict the numbers of sprints to work our way up to a specific backlog item. This allows us to plan over a long period of time. There are 2 ways we arrive at these values. The first variant we do with teams that have not been working together for so long. Magic estimation is suitable for this. We start with a user story and put the node on the whiteboard. Then we take another user story and estimate. Is it the same size, bigger or smaller? After, we have arranged both user stories accordingly. We compare them in relation to the ones that are already hanging there. Now we assign our numbers. The second variant is the planning poker. This is suitable for teams that have been working together for a long time. This explains why the playing cards down here in the middle don't accidentally look like they are from a game. Each team member gets a pack of cards. A user story is presented. After the presentation of the user story, everyone places one of these playing cards face down on the table in front of them. After all the playing cards have been placed, everyone flips over their playing cards together. If everyone has placed the same playing card, we assume that everyone has the same understanding of the size and complexity of a user story. If, for example, person A places a 3, person B an 8, and everyone else in the team a 5, then those who have the lowest and highest estimate present why they decided that way. This has the advantage that team members can now exchange information with each other. It also prevents the expert's estimate from becoming a lighthouse for the others' estimates. In the discussion about the estimate, the expert could say, "It is not that complicated." It is then explained why it is not complicated. The rest of the team understands this and now says, "Yes, we see it the same way now." Or maybe the expert says that the user story is much bigger than everyone thinks, because we haven't considered this and that. Then we play the next round of poker, in which everyone places their playing cards again. Probably this time we will get closer. But maybe someone will say that what was explained earlier is still not understandable enough. Then we have to talk about it again. This is repeated until the team has agreed on the size of the user story. On the one hand, this gives us a better estimate. On the other hand, we have the same understanding of work. Planning poker can also be played virtually on certain internet websites. As a further assistance, it is also possible to estimate in t-shirt sizes. In principle, it works like with the buckets above. Here is another question for you. Please answer within the next 15 seconds. What is a story point? Time is over. The right answer is number 1. Unit for relative estimates of stories. Last chapter. The thing about the plan. There are people who say that there is no planning in Scrum. Others say, we are agile now, we don't plan anymore. Or, we only think from sprint to sprint. None of that is true. A quote from Dwight D. Eisenhower, a former US president, is, "Plans are worthless, but planning is everything." We plan quite a lot in Scrum. We remember. The Agile Manifesto says, responding to change over following a plan. So we continue to make plans. The focus is on value creation, not on plan fulfillment. Every sprint, we do sprint planning for the next few weeks. Every day, we do a daily Scrum where we also plan the next 24 hours. We even plan in the sprint review through the feedback we get there. In the classical environment, we usually do this once for a large period of time, stick to the plan, and only make minor adjustments. In Scrum, as I said before, we do it all the time. So in Scrum, you spend a lot of time on plans. A final comparison. Agile planning can be compared to a weather forecast. Here, many people struggle with it. By constantly adjusting our plan, a transparency about how well we are doing in achieving our goals is established. Maybe you know the term watermelon status. This status is symbolic of the fact that we report the outside of a watermelon to our management. Everything is green in the budget, and we deliver it in the agreed time. But there is only a very thin layer of green, and inside it is deep red. We know that if we were to take a shortcut into the project, we would quickly end up in the red. By always saying that everything is in the green zone, however, we keep unpleasant discussions at arm's length. That is the watermelon status. In Scrum, we can say quite precisely when what will be done in the sprint. We do sprint planning with small user stories, so it should be easy to say what we will deliver at the end. Our velocity also helps with this. Also, rough planning like in 3 sprints, you can roughly expect this or that. Knowing that the product backlog can change. We are constantly learning new things. From sprint to sprint, our knowledge can expand and becomes more accurate. The next upcoming sprint can be predicted better than the 1-5 sprints in the future. It is the same in weather forecasting. The one-day weather forecast is more accurate than a 14-day forecast. It is of no use to us to fake a good weather outlook. If the weather forecast says it will be sunny and warm next weekend, we look forward to it. So, we plan to go to the beach. But what we don't know is that it will rain heavy and cool down. We could have known the truth from the weather report. We could have planned our weekend differently or taken the umbrella and warm clothes. In short, we could have reacted to it. Of course, we also have this issue in Agile planning. Our planning is designed to be adaptable. This allows us to make conscious decisions about how we deal with certain situations. Let us say we realize today that we will not reach our expected goal in the next 3 sprints. Then we can immediately talk about it and think of countermeasures, such as: can another team support us? Can we maybe prioritize certain topics down? And does a different order in the product backlog make sense? Open and honest communication now allows us to respond. Covering something up over and over again doesn't help us. It can also make the situation even worse. Especially in the classical environment, you often have watermelon status reports. In the Agile environment, you still have to get used to the fact that an open status and visible plans are not a bad thing. And here is your last question. You have again 15 seconds. Agile project management can be compared with. Time is up. The right answer is number 3, a rainbow pie. Thank you for your participation in this training. I hope you learned something and were entertained.